I want to end our discussion on ellipses with some discussions about the physical properties of an ellipse and some examples of ellipses. Now, ellipses can be found both in nature and science, and in nature, one of the most common places that ellipses are found are with the orbits of planets in our solar system. Sometimes people think that planets revolve around the sun in a circular manner. However, they actually revolve around the sun in an elliptical manner. Now, the ellipse is actually very, very close to a circle, so the two foci are very, very close to each other. However, it's not quite a circle. It does end up being an ellipse, and the sun ends up being at one of the foci. So the planets are actually rotating around the sun in an elliptical pattern. The other area where we commonly look at ellipses is in different branches of science, and in particular, we look at the reflection properties of ellipses, which are different from the reflection properties of parabolas. Remember that when we have a parabola, the reflection property is that any sort of light rays or sound rays or other waves or anything that goes directly into the parabola, all of these things are reflected into the exact same point, which is the focus. So here we have things that are moving parallel, all getting reflected into one point. We have a different reflection property when it comes to ellipses. I'm gonna do my best to draw a somewhat large ellipse so that we can have a look at this. So let's say we have an ellipse and the foci are here and here. This is just drawn by hand, so it's not going to be perfect by any means. But if we have an ellipse, any sound waves or light waves or anything that's sent out from one of the foci is going to be reflected off of the ellipse and sent directly to the other focus. And it doesn't matter what direction they're sent in, the shape of the surface is such that they will be reflected off the surface from one focus to the other. Just going to draw a few more of these so you can get a bit of an idea. These, of course, should all be straight line segments, but I'm drawing everything by hand on my iPad, so of course it's not perfect. Now, this is a very useful reflection property, and it comes into play in different places. One of these uses actually involves the treatment of kidney stones. Which hopefully you're never unfortunate enough to have. Kidney stones used to require surgery for removal if they were too large. And there are situations where people still have to have them surgically removed. However, there's another treatment option that actually involves ellipses. What they do is they take the patient who has a kidney stone that's too large to be passed naturally, and they put them in a device. It's almost like a bathtub, honestly, but it is shaped like an ellipse and a three-dimensional version of the ellipse. It's actually called an ellipsoid. And what happens is they're placed in the ellipsoid so that the kidney stone is put exactly at one of the foci. And then at the other foci, there is a device that emits sound waves. And what happens is these sound waves are emitted in every single direction. However, they all bounce off of the edge of the ellipse, and they all get reflected to that one point, the other focus, where the kidney stone is. And in some situations, this is actually enough to break the kidney stone into smaller pieces so that they can be passed through the system without surgery, and the patient is spared the trauma of surgery, and they can recover within days instead of weeks. So this is one really interesting use of ellipses, and it's actually improved the quality of life of many people who have had kidney stones. Another use of this reflective property is actually within certain buildings. There are different buildings that have rooms that are elliptical shaped. Again, we're looking at the three-dimensional version of an ellipse, so an ellipsoid. And what happens is, if you stand at one of the foci and you speak very, very quietly, you whisper, what happens is, even though you're speaking quietly, the sound waves from what you're whispering move in every direction, and they're all very, very, very quiet and soft, but every one of them gets reflected in the direction of the other focus, and so anyone standing at that other focus ends up hearing what you're saying, even if these foci are quite far apart from each other. These are called whispering galleries, excuse me. Whispering galleries. And there are several famous ones. You can actually Google this and you'll find a Wikipedia article that has a long list of them. But there's one in the US Capitol building called Statuary Hall. And there are stories that John Quincy Adams placed his desk at one of the foci so that he could overhear some of the other politicians maybe talking bad or plotting against him when they were at or near the other focus. So this can be used to spy on people, to be honest. But then also there are other places that have rooms that are this shape. In Salt Lake City, the Mormon Tabernacle, which is one of the buildings of the head of the Mormon Church, is built in this way so that when a choir is singing or a band is playing at one of the foci, the sound waves are bounced in all directions. And of course, if you're at the other focus, that's going to be where everything is bounced back most perfectly. But this shape still helps to make the room better acoustically, so that wherever you are in the room, you're able to hear a little bit better than if it was shaped like a rectangle or some other shape. And these are just a couple of examples of where ellipses can be found in the real world with different applications. I want to encourage you to do some Googling online to learn more about real-life applications of ellipses, and of course take a look at some of the example problems which do cover some of these different applications.